Hello, you are welcome to New Focused Approach to Mathematics Basic 8. This is the revised edition. And in this lesson, we are looking at expressing integers to a given number of significant figures. This lesson can be found in page 17. Now, I'm going to go detail about significant figures. Even though in year 8, we are looking at numbers which are not decimals. But I will generalize all significant figures so that we'll take few examples here. In year 9, we'll look at videos that could also help us to do the decimal aspect of it as well. Okay. So what is significant figures? By simple definition, which we have a lot about, people have different definitions. The one I just found that I feel is okay for me is that it's talk of significant figures of a number are those digits that carry meaning contributing to its precision. It tells how precise a measurement is when taken. Okay, so mostly significant figures are used in measurement. Okay, mostly they are used in measurement to tell how precise the measurement is. So we will take some few rules, okay, that can govern us to understand how to convert number into significant figures. The rule number 1 says that all non-zero digits are considered significant. All non-zero digits are considered significant. So 46, there are two significant numbers. 134.29, there are 5 significant figures here. So here 1, 2, 3, 4, 5 significant figures, 1, 2, 2 significant figures. If I write 5, 7, 8, 9, there are 4 significant figures over here as well, right? Then number 2, all zeros between non-zero numbers are always significant. All zeros that comes in between are considered significant. So here we can think of having 1, 2, 3, 4, 5, 6, 7 significant numbers here. And here we can consider 1, 2, 3, 4, 5 significant numbers here. Okay, so the zeros are in between non-zero numbers, and so they are considered significant. Then point number 3, all leading zeros are not, let me make it capital not, take note of that, are not significant. They are not significant. For example, if I say 0.000742, here because these zeros are leading zeros, they are not significant. So we have only 3 significant numbers here. If I bring 0.4, then I'm going to have 1, 2, 3, 4, 5 significant figures here, right? So understand that all leading zeros are non-significant. Okay, but the moment I put a number here, maybe I put 8 here, then it becomes 8.000, then it becomes significant. That means I'm going to have 1, 2, 3, 4, 5, 6, 7 significant numbers. So what will happen to this? How many significant figures do we have here? Sure, the answer is 4 significant figures. Now point number 5, all zeros which are simultaneously to the right of the decimal point and at the end of the number are always significant. All zeros which are simultaneously to the right of the decimal point at the end of the number are always significant. Now look at this, this is amazing. If I have 3.67000, you see there's a decimal point and all these numbers are significant. And so here I have 1, 2, 3, 4, 5, 6 significant figures. Look at this number. Here I'm going to have, these numbers are not significant, but rather we have 1, 2, 3, 4, 5, 6 significant figures here. Does it make sense? Good. So all zeros simultaneously to the right of the decimal point. The decimal point is here. So the numbers that go to the right, okay, and at the end of the number are always significant. So not the ones leading, but the ones at the end of it are significant. So 43.000 have, over here we have 5 significant figures. 1, 2, 3, 4, 5. Good. Now let's look at the 5th point. All zeros that comes after non-zero number and there is no decimal point are not significant. And this one too, let me say capital not significant. Be careful. This is where the confusion comes a lot. All zeros that comes after non-zero number and there is no decimal point, they are not significant. For example, if I write 37,000, okay, these 3 zeros here are not significant. So here I will say I have only 2 significant figures in this number 37,000. So if you ask me to run this number, to run 37,000 to 1 decimal place, okay, I'm going to have only 1, that's 3. But because the 7 here is more than 5 or 5 and above, I'll run it off and make it 4. Then I will replace all this with zeros and say 0, 0, 0, 0. And so 37,000 to 1 significant figure will be 40,000. I hope it makes sense. Be very careful with this part, right? So again, we can say 144,300 has 1, 2, 3, 4, 5, 6, but then it will have only 1, 2, 3, 4 significant figures. So if I ask you how many significant figures has this one, it's only 4, right? Then this one will have only 2 significant figures, even though it is 43 million. Now, I'm sure you've got the fair idea about the rule. Now, my question here is, how many significant figures are there in the following numbers? How many significant figures are there in the following numbers? The first one is 5. Beautiful. Second one is what? 1. Good. That's true. Third one is 4. Good. Then the last one is also 4, because we have 1, 2, 3, 4. The rest are not significant, but there's no decimal point here. So that is 4. Right. Now, look at this question. Express these numbers to the required number of significant figures. This is the number. We want to run it to 3 significant figures. And so we are going to have it as, so we count 1, 2, 3. So we have 9, 8, 6. But then the 6 that the number that follows the 6 is 7. So it's going to run off to make it 7. Now after that, how many digits do we have left? 3. So we put in 0, 0, 0. So instead of 986,742, to 3 significant figures will give us 987,000. Then the second number, we have to run it to 5 significant figures. So let's count 1, 2, 3, 4, 5. So we have 1, 4, 7, 8, 6. But the next number that follows 6 is 4, and that cannot run off. And so we are going to have 1, 4, 7, 8, 6. Then the last 2 digits, we leave them 0, 0. And so this become 1,478,600. Good. Then let's see the last example. The chemical formula for a compound indicates that it consists of 7,200. 7,200. Okay, now the question is, express this to 1 significant figure. 1 significant figure. So 1, that means 7 is the only one number, or the first number. Ideally, this has only 2 significant figures. So if I'm to leave it to one significant figure, I'm going to get 7. Because the 2 here cannot add up, I'll just replace them with 0, 0. So that becomes the answer. I'm sure this has really helped you to understand the whole concept of significant figures, which you are going to use now in year 8. Year 9, you do the same thing. Senior high school, 1, 2, 3, you'll be running it through. All right, so go ahead and solve more questions. Thanks so much for watching.